Okay, so we are on an ongoing project, and this is Siddharth Waddi, and welcome to ML Ticket. And we are continuing with our project that is a regression problem that we have addressed. It's a housing problem, housing database, where you have taken a database on the California 1919 housing census, and we have to predict the final house value, and that is our prediction. Till now we have done our uh, visualization. We have completed our visualization, but now we have to get into data cleaning. Okay, so let's just get a little bit of idea that what we mean by data cleaning. So before data cleaning, let me just start with a slide. So data cleaning is like cleaning up your data. Our data contains some of our data contains the data is not absolutely correct in every form. If you think of it, previously when we were visualizing the stuff, I said that the data was in a very different scale. Let me just get back to that slide so that you can understand. Let me see if I can get to that slide. Yeah. So the conclusions from the histogram, if you keep an eye on the fifth point, that is the attributes are very different scales. Okay. So okay. Hope you can hear right. Let me just check once. Is it audible? I hope it is audible. Yeah. So okay, let me just continue. Okay. So if we take a look at the fifth point, that is the attributes are very different scales, right? So the many attributes that we get in our columns and our data points have different scales. Some of the attribute range between 0 and 1500. Some attribute range from 0 to up to 5 lakh. Some range from 0 to 1. So they have different scales, and we cannot feed all these data points with different skills into the machine learning model. And it will create a mess. Okay, at some point or the other you won't get the accuracy that you were searching for. Okay, so this is the problem that we are trying to address, and data cleaning is a part of pre-processing. As we have said, as we have mentioned, I have mentioned that there are three parts to the rough that the any machine learning project can be divided into three parts. That is data visualization, data pre-processing, and ML algorithm. Yesterday we completed with our data visualization part. Now we are entering into data pre-processing. Everything that goes from now on will be under pre-processing. Okay, so the first step of pre-processing is data cleaning. Okay, and the first step of data cleaning is missing values. Okay, this is a very interesting topic, to be honest. Missing values. So we will start today with the missing values, and to be honest, I'm going to talk a great deal about missing values because most of the data set that you will be getting will contain missing values. Okay, so you should have a very clear understanding that how should you handle these missing values. But first, let's talk about that why we need to deal with these missing values, right? Okay, so let me just present my screen now and start right away. Okay, so I hope you can see. So let's get started. So the first thing that we are concerned about in data cleaning is missing values. So First, we need to understand that why it is very important for us to tackle with these missing values. So let's consider a situation. Imagine a situation where your girlfriend asks you when is my birthday, and you, my fellow friend, don't remember, and the information is missing from your mind or your head, whatever you can call it. Now tell me, does that put you in a very good situation? Okay, I'm just making a joke here, but don't take it personally or something like that. But the point is, uh, this kind of situation is not intended. You don't want this kind of situation in your life, right? And you can be in trouble if you don't have information in yourself sometimes. So similarly, if our data, some of our data is missing, some of our data is missing, then if somebody asks our model about that missing values, it won't be able to answer, or it will answer it in an inaccurate way. So we don't want that. So that's why we don't want our child to have missing values, or the model to have missing values. And machine learning algorithms do not like missing informations. And it's like serving you, you are in a restaurant, you place an order, and the waiter comes and serves you with an empty plate. You don't like that, right? Because the food is missing. And in the similar way, the machine learning algorithms also do not like missing values. So even if we have missing values inside the datasets, we need to do something about it. But most of the time, when you are working with real-time data sets, or raw data, or very big data sets, there is a high possibility that you will have missing values, and that is nothing to be very concerned about. To be honest, this is quite normal, to have missing values in your data set. So let's see. From now on, I'm going to code, and I'm I'm going to show you that how can you understand these missing values a great deal. Okay, first let me just pull up I'm going to show you the dataset that we are using right now. Remember, to get the first 5 rows of the dataset, I can use dot head. And since our housing contains our training dataset, so we are pulling up training dataset. Remember that from the last session, I have deleted the median house value from the. I have temporarily deleted or detached it from the data set, so that we can work freely, because some kind of if I make some kind of transformations over the data set, and somehow it gets affected, it will generate error in the later stage of our later stage of, we won't be getting good accuracy and all. Okay, so let me just start. Now, how would you understand that you have missing values? We have actually seen here, very at the very first code of our machine learning sessions, we have seen that this total bedrooms contains some null values, right? Now, null values are is known as the missing values. Okay. Now, many of you may confuse in these two parameters, these two terms. So let me just clear it out for once and for all. That is nan and versus null. If you think the nan and null are the same thing, then my friend, you are very wrong. Okay, nan and null are not same at all. Nan is the abbreviation for not a number, and null is just a null value. If I talk in terms of set theory, null is represented by 5. Okay, but nan is an empty set. Nan is an empty set. Null is actually a curly braces. Within the curly braces, we have 5. It is considered as an event inside the set theory. Okay, so it is very important for you to understand the difference between nan and null. But in most of the cases, in most of our data sets that we encounter, nan and null are not it's not distinguishable as such. Okay, but it is very important for you to understand that both of these things, though they have very common attributes, we have many common attributes between nan and null, but they are not same. You have to understand this. Make it clear in your head that nan and null are not same. Okay, so how do you check your dataset contains null values. We have already seen this from the very first session that yes, we have null values. But let me show you some of the efficient way that you should check that if there is a null values or not. These are so important that our pandas dataset, pandas library provides us with special methods so that we can do this stuff. So what is the name of the method? Is it is known as is null. As from the name we can understand that it tells me that if the value is null, it will return true, and if the value is not null, it will return false. So let's see what happens. Okay, if you can look at it, we have the entire data set, but instead of data points we have false, 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 false. We don't see any kind of true, because false means the data is present, and if the somehow we find something true, then the data is missing. Now you may argue that I cannot see any true data. How can I make sure that there are null values? So Python, yeah, if you go deep into Python, you can find a function which is known as any. Okay, it what it does, it takes up the it sums up everything and tells you if there are any null values or not. So if you can look at the output that we are getting right now, we have every column represented, and we have false behind that until and unless we came across total bedrooms, which is marked as true. So we can understand from this the total bedrooms attribute or the column contains some null values, and we have to be concerned about it. Now you may argue, okay, I want to see those null values. I'm not seeing those null values actually. I can You are telling me there are null values, but till now I have not seen those null values. I say yes, and but you should see those null values. So let's take an variable. I am naming it sample in complete rows, and I'll be storing the null valued rows inside it. I am going to store the first 5 null valued rows, though there are over 200 such rows, but for just an example. Okay. I am giving it an axis of one, that is it represents columns. So I am only concerned about the columns. That why I am giving a parameter, passing a parameter that is axis equals to one, so that it picks up the columns. Okay, I am storing only the first 5 rows, and let me just print it out. Fingers crossed. Oh, we have an error. Function object does not have anything. Okay, what is the problem? Oh, I have forgotten the parenthesis. Okay, look at it. Now, I want you to note the total bedrooms column, and you can see that it is labeled as NaN, so not a number. It is also known as a null value, or basically the data is not present there. It won't be sitting blank. It won't be sitting blank. Most of the cases, it won't be sitting blank. And if you look at the original Excel file, I'm going to open the CSV file in Excel, you may see a blank portion, but since we are viewing it through pandas and numpy, it won't be sitting blank. It will be having either null or nan. Most of the time it will have an nan. Okay, because a blank space is not a number, right? But blank space is not null also. You have to remember this. That's why most of the time you will find nan, but nan is null only. Okay, here we consider nan as null only. So here we get the first glance that we have the total bedrooms as nan. uh, you can see that all the other data points are present, but in case of total bedrooms we don't have the values. So So there are some couple of ways that we can handle this. To be honest, there are three exact ways to handle these missing values. Mane, at till point we have three. Mane, I know at least three. So I'm going to discuss them extensively with you. Though we are only going to use one of them, but I am going to extensively discuss every one of the options so that you have a clear understanding about when to use what. So let's get back to our PPT. Okay, we understand. So what is the solution to the missing values? The first solution that we have is delete the entire column. If we delete the entire column, then we have a solution, right? Um, but it also comes with a disadvantage. If we delete the entire column, then we are losing on a lot of data, right? And if by any means the data is correlated with the final value that we want to predict, then it will be disastrous to delete the entire column. But still sometimes we need to delete the entire column. Deleting the column will be beneficial. When it will be beneficial? When to use? When the columns contains more than 90% missing data. Suppose there are 20,640 rows, right? And under total bedrooms, about 20,000 points are missing. So 90% of the column is null only. So there is no point in doing anything else. We can just delete it. We can just drop the column and we can move on. Okay. So let's see that. Okay. I'm not going to mess with the original dataset right now because I'll show you an efficient way of doing that. But I'm doing it manually right now. But let's see. So what is the first option we saw? We are seeing we can drop the column. Okay, so we have sampled rows drop. Now we will be talking a great deal about this drop thing, the delete thing. Um, if you watch closely if you were attentive in my last session, I've used this drop thing earlier also, but I have not explained it in a elaborate way. Now I'm going to explain it in an elaborate way because this is the time. So what is the column that we have missing values that contains missing values is total bedrooms, right? Hope that I can spell it right. And we want to drop an column, that's why axis equals to 1. So drop function, what the drop function does, the drop function in pandas is actually meant for deleting stuff. Okay, so if I drop this column, if I have to drop a column, then I have to name a column. Okay, and I have to set the axis equals to 1. If axis equals to 1, I have also said this previously, but let me repeat. Axis equals to 1 means columns, and by default axis is equals to 0, that is rows. So if you want to drop a column, then we have to set the axis equals to 1. But if suppose we want to drop some of the rows, okay, then we can you just let it be. We don't have to mess with this axis parameter. We can just mention what the columns are, what rows that we want to delete, and that's all. It will take care of it. But now I am just dropping the total bedrooms column. So let's see what happens. Okay, so if you can see that our data and our sampled incomplete rows does not contains the total bedrooms, right? So we have dropped it. This is the first option. Okay, this is the first option that we have. But as I said, if we have very few missing values, in this case we only have around 200 missing values. We have seen that about a little above 200. Okay, so that is negligible in when compared to 20,640, right? So we should not drop the entire column here. So option 1, or dropping the entire column, is not a good idea, at least in this case. Let's see what is the second way to do it. Delete the entire row of missing values. Now up to now we were deleting the columns, okay, but now we are going to delete the entire row. Mane, I am going to delete this entire row. If a row contains any missing value, then I am going to delete that entire row. If any row in any column there is one missing value, it will delete the entire row. Okay, this is another option. When it should be used, when to use, when the rows also contains missing values. That's quite obvious. Now think like this, imagine a situation where these are missing values, all these are missing values, and only one particular data point is present, all the entire row is consist of null or nan values. Then we can drop that in, then we can choose this option. But here if you can see that we have only one column with missing values, and all the columns are completely fine. So I don't think that this particular option is very good in our case. Okay, but since I am showing you it in an extensive way, I am going to consider it as an option, and let me just delete the entire row. And thankfully we have a slightly enhanced method for this. Instead of using drop, I can use drop na, that is drop nan values. Okay, to drop NaN values, I can use drop NA, and it will search for all and it will search for the through the entire data set, or in this case only 5 rows, and it will delete the number of rows, delete the rows that contains any null value. So I am selecting a subset of total bedrooms, otherwise it will be going through everything. I am not setting the axis equals to 1 or 0, because by the default the axis is 0, and I am only considering rows. That's why I am not writing axis equals to 0. So let's see what happens. Look, we don't have anything under those names. Okay, though all the rows are deleted. Now if you can see that I have in all of them, in both the options, I have not placed in place equals to true, right? So this is the second option. Since I have not placed the in place equals to true, then so it is not affecting my sample incomplete rows directly. Okay, it's just creating an instance where these particular attributes are used. So what is the third way that I am talking about? Fill the missing values with some value, and this is the one of the most effective way. Sometimes most of the times you won't be having a row entirely null, okay, or a column entirely null. Okay, it will be, this situation will be very frequent, that you will, out of about 1 lakh data points, you will have only about 200 missing values. And in that case, that this is the most frequent case, and in that case it is very wise to do this third option, that is fill the missing values with some values. When to use? When we have few missing values. In this case we have 20,640 missing data points, and 200, a little above 200 missing values. So we will be using this particular technique. Now the question arises, how do we fill these missing values? What is the number that we should fill it? Now there is an argument going on over the internet, that what is the perfect method to pick a value. There are multiple things that you can do. You can use standard deviation, and with some complex formulas, use median, mean, for 25 percentile, 75 percentile, anything that you want. Okay, but it is a very debatable topic, that what to use and what not to use here. And to be honest, I am going to leave you at that point, for you to decide what to use and what not to use. Okay, I'm not going to argue with it. I'm just going to show you an example that how I'm going to do it. And since I don't want any kind of mess, I am going to use a median value. I'm going to use the median value of the row. Sorry, of the column. So how do I calculate the median value of that column? Um, Let me create a variable, take it variable called median, and let me select that particular row. Sorry, column. I'm sorry about that. So total bedrooms. And how do I find the median? It is very easy. You just write dot median. I mean, it's that easy right now. Nowadays, it's that easy to find the median. You don't have to think about anything else or something like that. So let's take incomplete rows, and I'm only concerned about total bedrooms. Hey, sorry. Yeah, total bedrooms. And we have to use a you have to fill the null values. Now it is very convenient to do this filling things inside our using pandas and numpy, because just like drop na, which drops any null values, there is a method known as fill na, which fills the null values with the value that we want. So what is the value that we want? We want the median value. I am taking this particular variable inside it, inside my as an attribute, and it will fill the particular null values with this median value. And to be honest, I want to reflect this on the sample incomplete row. That's why I am going to say int x equals to true. Remember that previously I have not used int x equals to true, and by default int x is equals to false only. So let's see what happens. Okay, nothing happens. Okay, just let me just pull up the sample incomplete rows. Okay, there you go. Now, if you can see, previously when we had our sampling incomplete rows, we can see that the total bedrooms is nan. Now, if you can see, it is filled with a particular value, that is 433. That is the median value. If you take all the 20,000, sorry, we are only considering 16,000 in this training points, right? Training data set. So if we are considering 16,000 training points and taking the median of it and calculating the value, yeah, the value will be 433, and that's what is placed in every null value here in this column. So this is the way that we should be doing stuff. We should be doing stuff. I have showed you almost every possible way that I know, that how to deal with missing values. If you by chance get to know some other values, I would like you to share with me, because sharing is caring, I guess. Because I don't know everything. Okay, I just know that the tip of the iceberg. Okay, the whole thing is a very very huge. It is almost impossible for a person to know everything in this case. So I've used the median value, and to be honest, median values are quite stable, and machine learning algorithms are very, not so angry with this median value. And if you feel the missing values with the median values of that particular column, algorithms can work with it. So I'm using the median values. But to be honest, this is not the way. This is the manual way that I have done this thing. Okay, but to be honest, you should not do this thing like this, because scikit-learn provides us with special libraries for doing this kind of stuff, and we should be using those only. We should not use um, these methods, though these methods can be used. Okay, but scikit-learn, since scikit-learn provides us libraries, so it is much faster and efficient. Because now you may argue that how it is efficient, how it is, I don't see the efficiency. And if you do it some other way, it will be generate the output in the same time, right? Yes, but here only we are considering a very small data set. But if we are considering very big data set, like which contains about 1 million or 2 million, about 4 million data points, if we consider that type of data set, then it will slow down the process. Okay, the output generation will be slowed down, and then it will cause some error. It may run out of CPU, it may run out of RAM. So that's why it is better to use scikit-learn's provided library. So what is the name of the library? It is known as imputer. Okay, the name of the library is imputer. Now let me show you something very interesting from sklearn. Okay, sorry, misspelled it. Okay, what do we have here? Okay, import error. We cannot import name imputer. Cannot import the imputer. Okay, so what is this thing? We are getting an import error. So what can we do about it? Okay, so let's see what can we do. Uh, okay, nothing is coming to my mind. If nothing is coming to your mind, just do one thing: copy the entire code, paste it in Google, and see what is generated. Okay, let's see what we can. Okay, let's see. We have a GitHub way. Import error cannot import, right? Okay, so what solution that do we have? Um, a new scikit-learn version 0.2.2 was released yesterday, but there are other errors of using this version. We should keep on using 0.21. Okay, what are the things that is going through? Okay, so I understand something. Out of this thing, I can understand one thing. J, this imputer, this class is not being, I cannot use this class because of some kind of upgrade, I guess. So what is this upgrade? Now note that one thing that I all that this is the reason that I am telling you, Jay, you should never trust your code. You should always trust your understanding. Why so? Because sklearn or scikit-learn is a very volatile library. It changes so fast. It changes so fast that you won't be able to understand. You won't be able to track. You can write a code right now, leave it for 3 or 6 months, run it again, it will generate error because the libraries that are present in particular sklearn packages will be reallocated. Similarly, this particular imputer class is also reallocated. I want you to go online and search this problem. It is a very common problem that people have about this imputer library because previously in this sklearn 2.1 0.2.1, sorry, 0.21, the imputer class was present under sklearn.preprocessing, but after the upgrade it is not placed under sklearn.preprocessing, rather it is placed under sklearn.impute, and the name is also changed, has also changed, that is simple imputer. Let's see if it runs or not. See, we don't have an error. This is the reason that I at the very beginning of the session I told you, Jay, not to believe anybody's code. So believing in anybody's code is not wrong, but it is not ethically wrong. But at some point or other, if you don't understand what you are writing, you will face this kind of errors, and you won't be able to understand why you are facing this error. So it is better to understand the reason why you are writing that line, because someday if this entire library gets diminished or it is removed in some way, you can find some alternative ways to do it. Okay, there are tons and tons of examples that I am going to give as we go, that will support this theory there of mine. Okay, so what is this imputer class does? This thing, it does exactly the same that we did here. We have to write so much code, right? We have to write too much code in here, but using this particular imputer class, we can do this in a single line. Maybe not a single line, but okay. Let's see. First, create an instance, imputer will imputer, yeah. And in this case, it takes up a strategy. Strategy simply means that what kind of values that you want to fill your data set with. So I want to fill my data set null values with the median values. Let's run it. Okay, so we have it. But to be honest, if you look at the data set, we have this ocean proximity, which is not, which does not contain any kind of null values. And to be honest, the we cannot generate a median out of string values, right? So we are not considering this particularly particular column. So that's why I'm just dropping it for now. So I'm just creating a housing num and dropping this ocean proximity. Hope that I've spelled it correctly. And I want to drop a column. That's why as x is equals to 1. Okay. Let's see the let's see what we have here. So housing num. Okay. Okay, now everything is in float value. We have only the columns that we have float values. We will later attach this ocean proximity, don't you worry. So how do we do this thing? How do we apply this thing? This thing is still not applied, right? So how do we apply this thing? So we have to use what is very common. We will learn it in a very extensive manner when we start with the ML algorithms, but still I'm giving you a brief idea. We are going to use a thing which is known as fit and transform. Imputer dot fit upon which data? Housing num. Okay, what is this fit thing? So fit thing actually prepares the data over whatever model that we have generated. This imputer class is a, consider it as a model or a something. How do I explain this? Um, okay, we have done this thing, right? We are filling each value, right? For filling each value, we have to first calculate the median. We have to first calculate the median of of that particular row, right? So consider it as calculating the median of every row, and it will it will put all those missing values. It will put all the median values in the place of those missing values. You will understand better when I do this. Okay, it is little hard for you to understand right now about fit, because to be honest, it is a attribute of the ML algorithm. So it is a little early for you to understand this particular fit function. But just consider this, J. Fit gives you a staging area. It stages your particular data set to the point where it is ready for the transformation or the filling up the missing values. Okay, so I have staged my data set right now, but still now the data set is not filled with the missing values. The missing values are not replaced by the median values. So what do I need to do that? If we want to do that, we have to use something which is known as transform. Okay, we will be doing this after a few things, but I need to explain you something. So let me just mm, make sure that the median values that we have is actually the median values. I am telling you these are the median values, but how can you be reassured that these are the median values? So let's see. So imputer class provides us with uh, what do you say, method which is known as statistics, and it gives the median value of each column. Consider this. So we have how many columns? One, two, three, four, 5, 6, 7, 8. 8 columns, right? So we have 8 values. 1, 2, 3, 4, 5, 6, 7, 8. Okay, right. Okay. And we are only considering, since we are only considering the total bedrooms, it will, I am only concerned about this 1, 2, 3, 4, 5, fifth column. Okay. So let's consider the fifth value. 1, 2, 3, 4, 5. 4, 3, 3. Um, does this look familiar? Let me get back to the data that we had. Oh yeah, our data is filled with 433. So 433 is the median value of total bedrooms. Similarly, all these values that we are looking at are the median values of respective columns. Why it is generating the median values for respective columns? We do have only null values in the particular fifth column or total bedrooms, right? But you have to understand that sometimes in this case we have only one column with null values. Sometimes there are multiple columns with null values. What happens then? So imputer class, to be on the safe side, imputer class generates all the median values of every column. Now if he sees a null place or a missing value or a blank or a nan, okay, it will just place this particular value there. Since all the other columns does not contain any kind of missing values, it won't be placing any. But since the fifth column, that is the total bedrooms column, contains missing values, it will place 433 in that case. Okay. So still you may argue, nah, okay, I understand this 433 is the median value, but I cannot be assured that these are the actual median values. Okay, I can show you that thing. So we are considering housing num, and I'm considering the median, right? And if I just give you the values, if I use a method known as values, it will give you the values of individual columns. Now, if you look at it, these two arrays are exactly same, exactly same to that very decimal point. So we can be reassured, more than assured, that these are the median values. So how do we do this? Let me just create a variable x that will store the final uh, output after doing filling up all the missing values. So I am going to consider a variable x, and I am going to say imputer dot transform, and transform what? Transform housing num. Okay, so let's see what happens. Nothing happens. So let's print x. See what we have here. Okay, what do we have here? Okay, this is complicated, right? Like, I don't understand, what is this? I have trouble understanding this stuff. Okay, just let me just pull up housing now for a moment. Okay, I just want you to consider the first column. Sorry, the first row. Look at the values. Now look at the first row. This is a matrix, right? This is a 2D matrix. First row of this array. Can you find any kind of similarity? Let's see. Okay, yeah, these two things are exactly same. So what it did actually? This is the actual data only, but it does not contain this indexing, this labeling, and this nice formatted way. It does not look like that. Why it is not looking like that? Because imputer class returns or outputs a numpy array. This is a numpy array. This is what you known as a numpy array. And numpy, to be honest, to be specific, this is a numpy 2D array. Imputer class returns always a numpy array. Okay, so but to be honest, we are not used to look at the dataset like this now. So we need to understand this, how to convert this numpy array into this pandas dataset. Okay, I think pandas should give us a class for this only. And to be honest, you are right. We have a class for this. So let me consider a variable, and PD is pandas data frame. What are the data points? What are where the values are coming from? From X. Okay. So it comes from X. That's okay. But what are the columns that we are going to use? We have to name the columns, right? We don't have the names of the columns inside X. So what are the name of the columns? But we have the name of the columns in the housing variable, right? So they it takes attribute known as columns. I'm going to say housing num, and I am going to use the name of the columns. Oh, it's not coming. Yeah, right. And another thing that we want, that is indexing. The indexing, and also we want the indexing of the housing num. So index how housing num dot index. It is that simple. It is not, the code is not very complicated, right? Just run it. Let me see that if we have here. Great. Yeah. Now we have converted it into a NumPy array. Sorry, pandas dataset. So that NumPy array is now converted into dataset. Now you may ask, Jay, how can you be so assured that this does not contain any null values? So let's see. Yeah. Remember previously we used to have these total bedrooms as true. Let me show you that output. Yeah. Look at it. The total bedrooms was true because it contained land values. But now, if you look at it, it does not contain any land values. So we have successfully dealt with the null values. So now our dataset does not contain any null values. We have 100% data, no missing values. Okay, so today we are going to stop here only. Next day we have a very important topic about how to deal with categorical values, and I am going to show you in a very extensive manner, the most extensive manner that you can ever imagine, that how can you deal with this type of categorical values. So do you have any questions today for today? Wouldn't sklearn prove problematic when used in an API then? Okay, of course, sometimes I told you, na, the sklearn is a very volatile library, right? So you have to check every time you start coding. For example, many a times when these kind of problems occur, sklearn, you have to only stick to one particular version. Okay, suppose you are making a big project, okay, and and you don't want these things to change very frequently. So you have to note down the version that you are using at that time, and you have to use that version for the rest of the project till the point that this new version has something very interesting that you need to replace. Okay, so it is very important at the to be reassured that you are using the same version. To be honest, when you are actually you are doing this kind of project, right, you create a file which is known as requirements.txt inside Python. It contains all the libraries of the Python that are used along with its version number. Okay, and to be honest, when you start running the file in others PC or any other computer or a laptop, it will download all those libraries with that same version only. Even if the new version is available, it won't be downloading that. Okay, if you get to a very depth of these things, you will understand everything. And if you have done a little bit of what do I say, web development, you should be very familiar with this requirements.txt. So any other question that you want to ask?
Yeah, I wanted to ask if we have like 40% of the data is missing, right? So in that case, what should we do? Like not the majority of the data, but like a high minimum, I'd say.
If you have a high minimum data missing, then it is very wise to use the third option that I have shown. That is replacing the missing values with some values, either
Yeah,
mean,
but
median, or
wouldn't
something.
API wouldn't like the outliers affect it, right? It would like deviate the median, right?
I don't get you.
Like let's say we've got like an age variable, right? So someone has inputted like a wrong data in it, and there's like an age there like some ages which have like 100 and 1000 years, right? So when we are calculating the mean or median of it, so wouldn't that high amount affect our average?
Okay, you are saying about if we have faulty data in our data sets, then if it will affect the median of the or mean of that particular data set. Of course, if you are talking about faulty data, then it will affect. But to be honest, these are some of the assumptions that you have to take, that the data set that you have is not completely faulty. Because if the faulty data points are present, that you have to be honest, you cannot do anything about it. You are given only, you are inputting faulty data into a model, and how can we expect it to learn something good from it? Maths is good till the point you give faulty inputs. Okay, if you do start giving faulty inputs, it won't be giving you any kind of a valid output. So, and to be honest, another thing, it is not like suppose we have created a model, okay, and after then we are giving this kind of faulty inputs like 1,000 years of age, my age 1,000 years, okay, this is not possible, right? And neither it is present in our data set. Then the model will understand that you are inputting something which is beyond the scope of its learning. It will generate an output which is not correct, which won't be correct. It will definitely generate an output, but it won't be correct because it is not fed with that data. Previously, when we have learned, if you can remember previously, in that, let me just show you once. Okay, hope that you can see my screen. Yeah, you can see. Yeah, if you can see this median house value, okay, not this median house value, this median age, housing median age, if you can look at it, there is no values after 50. It is like after 50 nobody lives, and this is not the case. So the data has been scaled down, right? But we have to make an assumption, we have to assume that the data set what you are given is completely right, that is after 50 there is no other age. We have to assume that people don't exist after age of 50. Because if we don't assume that thing, what are we going to do? You cannot do anything about it. You either have to you have to consider all the data that is present after 50, which is actually not given to you right now. Okay, so you cannot do anything about it if the data is not given to you. You have to work with whatever you have right now. So these are some of the assumptions that you have to make. Now if you input 66 in this case, now it will generate an output which is which won't be correct. And this is a problem, with this kind of data sets. And to be honest, when you are working with data sets, you will have a problem. But to be honest, in real life situations, if someday you start as an ML engineer, start your career as an ML engineer, these data sets will be pre-processed. There will be persons who will pre-process this data, and this kind of problem won't be occurring. But since I am taking this over from the internet, so, and this is a very old data set, like 1990. Okay, very old. That's why these are the some of the problems that we face right here. These are some of the assumptions that you need to make, that that you cannot, you have to assume that the data that is given to you is completely correct, because other than that you don't have an option. If you consider that the data is faulty and you start dealing with the faulty data, then to be honest, we have to spend a lot of time in pre-processing, and at some point we are going to transform the whole data set, and that is not right, to be honest, at some point. So this is the thing. Anything else, or your doubt is cleared, or you want to say anything?
No, thank you.
I hope that you understand the thing that I've explained.
Yeah, yeah, I've understood.
Okay, okay. So you people can sign off. If you have any question, just post it in the WhatsApp group. I'll answer as soon as possible.